One day a young wizard was walking through the hallways of her school. When she passed the headmaster's office, she heard a complaint coming through the door. Apparently the Ministry of Magic's spell was not working anymore, and they were having trouble finding new wizards to attend the school. The student knew that there must be some way to solve the headmaster's problem, so she went to the library, where she stumbled across a machine learning book that said that there was a non-magical way to find who was a wizard. All she had to do was to look at their DNA and find the wizard gene. Luckily, the school had already started taking DNA samples for current students, and she had a few samples she brought along with her from her time spent away from school. To find the gene, the student tried writing down all the possible combinations that she would need to try. However, there were several hundred of them, and she did not have enough time to try them all. Thankfully, the book said she could use something called Gibbs sampling. She started by making a guess at what the gene actually was. It didn't matter if this guess wasn't correct, because Gibbs sampling would help her find the right one. With her guess ready, the book said to try changing the first letter to see if she could make the guess match better with the data. The goal was to match perfectly with all the wizards and match on none of the non-wizards. There are 4 possible letters for any sequence of DNA: A, C, G, and T, so she tried all 4. When she tried using the letter A, she found that it was a good match, with wizards matching more closely than the non-wizards. When she tried using the letter C, she found that it was a poor match, with the non-wizards matching more closely than the wizards. When she tried using the letter G, she found that it was a fair match, with both the wizards and non-wizards matching about the same. When she tried using the letter T, she found that it was also a fair match, very similar to when she tried the letter G. To select what her new guess should be, she wrote the 4 possible letters on pieces of paper and put them into the sorting hat. She put in more pieces for guesses that were a better match, like A, and fewer pieces for guesses that were a worse match, like C. She then proceeded to pull the letter out of the hat. Now that she had a new guess, she could repeat the sampling procedure of the next letter to try to improve again. This time she tried changing the second letter in her guess, and found that using a C or a T both resulted in good guesses. Again she pulled a letter out of the sorting hat, and found that it wanted to keep the guess the same. But although the guess was the same, this didn't mean that she had found the correct gene yet, because it wasn't a match for all the wizards, so she kept trying. This time she changed the third letter in her guess, and found that using an A resulted in an excellent guess. Again she pulled a letter out of the sorting hat, and found that it returned that best guess back to her. Now the student felt she was getting close to finding what she wanted. This time she changed the last letter in her guess, and found that all the alternatives were good, but that the letter T gave perfect matches in all the wizards. Again she pulled a letter out of the sorting hat, and found that it returned the perfect match back to her. Looking at her guess for the gene now, the student realized that she had found what she was searching for. She had found the wizard gene that showed up for all wizards, and did not show up for any of the non-wizards she'd examined. And while it may have looked like the gene appeared by magic, the student knew better. This was just an application of machine learning. She had used Gibbs sampling to find a gene that matched across several pieces of DNA.